Hello students. So today discussion is about nitrogen from the chapter carbon and nitrogen. So nitrogen students, nitrogen is one of the key element in our earth atmosphere. Almost like 78% of the atmosphere air is composed of nitrogen in a diatomic state, which is N2 gas, where two nitrogen atoms are chemically combined with a triple bond N2. So nitrogen atomic number is 7 and its electronic configuration is 2s2 2p3. So why this component, why this element is so important for the human life as well as for the animal plant life? So we'll discuss in this chapter, in this video. So first of all, this nitrogen, students, was discovered by the scientist French chemist Antoine Chaptal in 1823 and named this gas is nitrogen. Niter means one of the famous salt which is niter, which is the famous salt which is potassium nitrate. This is also called as Indian saltpeter, so which is used in many uses, like in gunpowder also this is used. So where this niter can be produced by this element nitrogen, so it is named as nitrogen, niter producer. So that's how it got its name. So the main points about this nitrogen, let us discuss in this video. First, occurrence of nitrogen, student, like where it is available. Nitrogen is available, like we discussed, it is available in the nature in the free state. How much? It occurs in air at an extent of 78 to 79% in the air. Free state in the sense nitrogen gas directly a molecule of element N2, as well as it can also available in the combined state. This nitrogen element combines with various other elements and can form n number of different compounds, useful compounds. So first of all, in the combined state, students, we have in solids, liquids and gases, all the three states they are available. In solid, mostly it is available as like we discussed Indian saltpeter, which is also called as niter. The formula is KNO3, potassium nitrate, or chili saltpeter, which is sodium nitrate. So both contains the key element is nitrogen, as well as it is also found in all the ammonium compounds and proteins. Everything is because of nitrogen only. Nitrogen is present in almost all the proteins. So as well as in the gaseous form. In the gaseous form, it is available as ammonia in air when vegetables and animals decay. Decay means when they undergo decomposition. So this ammonia gas will be released into the air. So it contains nitrogen and as a vehicle exhaust gas in the form of oxides of nitrogen like nitric oxide NO, nitrogen dioxide NO also, and even some factories, industries also releases this nitrogen dioxide gas into the air. So in that form, in the gaseous form also, this nitrogen is available in the atmosphere, in the air. And liquid state as mostly acid rain. Like acid rain, what is acid rain, students? Like these nitric oxides, any oxides like carbon dioxide or sulfur dioxide or nitrogen dioxide, when they react with H2O which is present in the air, then they form the respective acids. For example, if CO2 reacts, what does it form? Carbonic acid. If SO2 reacts, what does it form? Sulfurous acid or sulfuric acid if it is SO3. If NO2 reacts, what does it form? Nitrous acid as well as nitric acid, HNO2, HNO3. So that means in liquid form also this is available, as well as liquefied nitrogen. It also has many uses, students, in our medicinal field mainly. So this is all about occurrence of nitrogen. Next, position of nitrogen in the periodic table. Nitrogen belongs to the 15th group in the periodic table and they are called as nicogens. Among other elements in this group are nitrogen, phosphorus, arsenic, antimony and bismuth. So nicogens means unable to breathe. These group elements forms not poisonous, suffocating gases, like unable to breathable, unable to breathe. The meaning of nico is, and gens means generate. So that's why. So nitrogen is there, but if you can we breathe only nitrogen, students? Can we breathe ammonia, the compounds of nitrogen? So they are the suffocating gases. They are not poisonous but suffocating gases. That's why, that's how they got their name as nicogens. Right. Next, laboratory preparation of nitrogen gas. How to prepare? So mostly this is the technique which we follow to prepare for the synthesis of nitrogen gas, which is sodium nitrite combines with ammonium chloride, and to produce, look at this compound, students, ammonium nitrate and sodium chloride. This compound, students, this compound which is ammonium nitrite is very unstable molecule, highly unstable molecule, as well as explosive molecule. That's why this reaction is carried out under the medium of water, H2O, under the solvent H2O. So these compounds were dissolved in what? H2O. By gently heating, we can make this ammonium nitrate, and further decomposition of ammonium nitrate. Why? Because it is highly unstable. You can see it will be decomposed into nitrogen gas and H2O. So in here we can obtain nitrogen gas, which can be obtained by the downward displacement of water. So by inverted the funnel, we can obtain the nitrogen gas. So next, this is the laboratory preparation. Next, physical properties of nitrogen. Physical properties means melting points, solubilities, densities, all comes under color. So nitrogen is a colorless, right? It's a odorless, right? It's a tasteless gas. Nitrogen is insoluble in water and slightly lighter than air. Why? Yes, nitrogen is insoluble in water. Why it is insoluble in water? Because, students, nitrogen is non-polar molecule. Water is a polar molecule. Because of the absence of the partial positive charges and negative charges, nitrogen is insoluble in water and it is slightly lighter than air. Nitrogen liquefies at high pressure and low temperature. And very low temperature. How nitrogen is available in the air at room temperature? As a gas, right? So in order to make it to liquid, we need to maintain high pressure and we need to reduce the temperature also. Very low temperature. So that's what the point says. And the melting point of nitrogen, look at the temperature. Melting point of nitrogen is minus 210 degrees Celsius. And that means at that temperature only it already liquefied, and its boiling point is minus 195 degrees Celsius. And it boiled already, it converts into gas at minus 195 degree Celsius. So when we try to liquefy it, look, imagine the temperature. It's very cold. That's why this liquefied nitrogen is used to store, in the medicinal industry used to store all the organs and all for the transport also. So nitrogen is neutral. Yes, nitrogen is neutral. It is inert. It is not showing any acidic or basic behavior. It's neutral and non-poisonous gas, but causes death due to the breathing problem. That's what I said. That's what they got their family name as nicogens. They like, we feel like in a suffocating, unbreathable kind of thing. If it is only nitrogen. So next, chemical properties of nitrogen. Combustibility. What is combustion reaction? Burning in air, in the presence of air. That is combustion. So nitrogen gas, students, it is not a supporter of combustion, or it's not a combustible gas, or neither a supporter of combustion. So action with litmus, it's a neutral to litmus paper. Action with non-metals. Nitrogen reacts with non-metal, students. If nitrogen reacts with chlorine, it forms nitrogen trichlorides. If it reacts with hydrogen, it forms ammonia, the most important compound from the nitrogen family. So nitrogen reacts with hydrogen in the presence of molybdenized iron as a catalyst. What is catalyst? Which increases the rate of reaction. What is molybdenized catalyst? If you increase the molybdenum acts like a promoter. It's like it increases the efficiency of catalyst. So that we can complete the reaction in a short period of time. So look at the reaction. N2 plus 3H2 gives rise to 2NH3. You can check the temperature conditions also. 450 to 500 degrees Celsius as well as 200 to 900 atmospheric pressure in the presence of iron and molybdenum as a promoter. We can synthesize ammonia. What is the use of ammonia? Coming slides we have the discussion about ammonia. We'll discuss there. So these are the conditions to synthesize ammonia. When nitrogen gas combines with hydrogen, we'll get ammonia. So next. Nitrogen combines with oxygen at about, look at the temperature range, 3000 degrees Celsius, it reacting with oxygen, students. So at the normal conditions, it doesn't. So forming nitric oxide. What is nitric oxide formula? NO. And the reason why do we have this slide, these reactions, is because acid rain. So these nitric oxide reacts with excess oxygen in the air and they produce nitrogen dioxide. So these nitrogen dioxide which are in the air, they react with water. And you can check, if they react with water, what are getting produced? Nitrous acid and nitric acid. This nitrogen gas reacts with oxygen to produce nitric oxide, and this nitric oxide in the presence of excess oxygen produces nitrogen dioxide. This nitrogen dioxide reacts with water and produces nitrous and nitric acids which fall as acid rains. So now, students, nitrogen also reacts with metals and they form the respective metallic nitrides. You already know metals are like highly reactive. They always show tendency to lose electrons, and nitrogen gains electrons in this case when it reacts with metals, but it doesn't react with all the metals and doesn't form all stable molecules. For example, sodium nitride, this is not a completely stable molecule, but it forms at 450 degrees Celsius. where the sodium with valency 1, nitrogen with valency 3, they combine in the ratio of 3:1 ratio Na3N. So, but instead of sodium, lithium nitride is more stable. Why? Because it has more covalent character than sodium. And with the second group elements like magnesium, so lithium and magnesium shows diagonal relationship. So magnesium also can form a stable nitrides like Mg3N2 at around 450 degree Celsius. So that's what the reactivity of nitrogen with oxygen as well as with the metals also, students. Next. So uses of nitrogen. So what are the uses of this nitrogen gas? What is nitrogen? Is it N or N2? N2 we are talking about. So nitrogen is used in the manufacturing of ammonia and fertilizers like ammonium sulfate or urea, etc. So this is the main use from nitrogen. Nitrogen is one of the key element for plants, for plant growth. To synthesize a protein, nitrogen is the key element, essential element, students. So that's why all the fertilizers, what is the use of fertilizers? Where do we use these fertilizers? Fertilizers are used for the growth of the plants. Yes or no? They supply nutrients to the plants to develop all the proteins and all the things. So here, what is the fertilizer? Can we give direct nitrogen? No. Then the compounds of nitrogen like ammonia, which is NH3, as well as from ammonia also we can synthesize n number of fertilizers like ammonium sulfates, ammonium phosphates, ammonium nitrates also. So here urea, ammonium sulfate and urea. What is urea? NH2CO, NH2. Urea is also one of the fertilizer. It contains key element nitrogen. So nitrogen is used to manufacture nitric acid also on a large scale in laboratories. Nitric acid also used in many synthesis reactions, students, one of the key acid. So for the preparation of nitric acid HNO3 also nitrogen is used. In atmosphere, nitrogen plays an important role to control the rate of combustion. This is also one of the key point. So combustion reactions takes place in the presence of N2 or in the presence of O2? In the presence of O2, students. How much is the percentage of O2 in the air? 21%. How much percentage is N2 gas? 78% almost, right? So it controls the rate of combustion, which means in case if nitrogen gas is 21, oxygen gas is 78, you know what happens? If the flame is burning with this much length, if oxygen is 78%, it will burn with this much length. That means we can expect a rapid combustion. You might feel like, sir, it is good only, we can, light energy will be great, we can experience more calorific value, right? Correct. But what about the forest fires? What about the accidental fires? Yes or no? Easily everything can be ignited. So that is very dangerous. So because of the presence of high percentage of nitrogen, it controls the rate of combustion. There is a difference between burning candle in the normal air and burning candle in the presence of only oxygen. The rate of combustion is more. It controls. So here nitrogen is used in the filling of containers containing tinned food, means like packaged food, mainly filled with nitrogen, for example potato chips packets and all. Why? Because oxygen, if normal air contains oxygen as well as water vapor, students, they are the reason for the decomposition reactions. That's why it is filled with nitrogen. Nitrogen is inert, so to maintain that inert atmosphere, so most of the packaged food are filled with nitrogen gas. And liquid nitrogen is used as a cooling agent for some reactions that require very low temperatures and preserving blood, eye, cornea, etc. and all. For even for the heart transport, liver, everything, all the transport, organ transport, which is used liquefied nitrogen. Why? Because at that temperatures we can expect the like lifetime of that particular organ will be increased, decomposition will be decreased. So that's why liquefied. Why? Because the temperature is very, very cold. So that's where liquid nitrogen is used. So nitrogen is used for filling electric bulbs also. The same electric bulbs also need an inert gas. So nitrogen is not an inert gas, but it has inert nature. So that's why nitrogen is also used for filling electric bulbs also. Next, the compounds of nitrogen, students, we have ammonia. In this video we'll discuss about ammonia and the compounds and its reactions, everything. So nitrogen forms three well-known hydrides. What is ammonia formula? NH3. Nitrogen combines with hydrogen. So this combination doesn't have only one compound. Total three compounds are there, students. One is called as ammonia, which is NH3. Other one is called as hydrazine, which is N2H4, and third one is called as hydrozoic acid, which is N3H. Among these three compounds, the main compound and the useful compound is ammonia. You already know the use, which is used as a fertilizer. So ammonia is the most important of these three hydrides, right? Correct. It is called as what is it? Ammonia is not a chemical name, students. Ammonia is a general name. What is the chemical name of ammonia NH3? Nitrogen trihydride, and its molecular weight is 17 grams. Nitrogen is 14, hydrogen is 1, 3 are there, so 14 plus 3, 17 grams. And the nature of ammonia is basic and it is a non-poisonous gas. So ammonia is a basic nature according to Bronsted-Lowry theory. Ammonia can accept H plus ion, students, so ammonia is a basic. So right. So preparation of ammonia. How to synthesize ammonia? Ammonia can be prepared by taking ammonium chloride plus slaked lime, which is called as which is nothing but calcium hydroxide. Slaked lime is a general name. Calcium hydroxide is a chemical name. So when the reactions between these two compounds can synthesize ammonia, which is NH3, you can see 2 moles of ammonia will be generated, and we can expect the byproducts of calcium chloride and H2O. So this is the general preparation methods of ammonia. Not only this, you already know one more technique, that is nitrogen gas, hydrogen gas, we can synthesize ammonia. N2 plus 3H2 gives rise to 2NH3. So physical properties of ammonia. Ammonia is a colorless, this is also colorless gas, and with a very strong characteristic smell. This is not odorless, it has a very strong smell, students, and that brings tears to the eyes and causes burning in the nose also. So very strong flavor, very strong odor ammonia has. So that is also used, one of the identification technique also for this gas. So ammonia has a bitter taste. Why? Because it's a base, obviously. Ammonia is extremely soluble in water. 1 volume of water can dissolve almost 1300 volumes of ammonia. Right, correct. Why ammonia is soluble in water? N2 is insoluble, but why ammonia is soluble? Like dissolves in like. Ammonia NH3 is also a polar covalent compound. Why? Because nitrogen being the highly electronegative element, there is a polarity. So clearly ammonia dissolves in water, students. So ammonia is a non-poisonous, but due to its basic nature, it can damage the respiratory system. So this is the point to be remembered. Next, chemical properties of ammonia, like how does it react with other elements? Ammonia is neither combustible nor supporter of combustion. In the general conditions, it doesn't support combustion, students, but at extreme conditions with oxygen, it will react. So ammonia turns red litmus blue. Why? Because it is a base. Bases turn red litmus to blue color, the characteristic color change. Ammonia fumes in air due to the formation of ammonium hydroxide. So ammonia with H2O, it can produce ammonium hydroxide, which is the fumes, which is mostly white in color. Ammonia is used as a reducing agent. You already know the what is reducing. What is reducing agent? Itself it undergo oxidation, it makes other compound to undergo reduction. So ammonia is also used as a reducing agent. Action with oxygen. So ammonia in presence of oxygen, pure oxygen, it burns to form a pale greenish yellow flame, student. The color change, the colors are very, very important in the exam point of view. Pale greenish yellow flame, and produces nitrogen gas as well as steam. Steam means H2 only, but very high temperature. So because we are heating it with very high temperature, NH3 plus 3O2 gives rise to 2N2 plus 6H2O. So this reaction is also mentioned in the synthesis of nitrogen gas. So we can synthesize ammonia from nitrogen gas, and we can synthesize nitrogen gas from ammonia also. Right, next, action with chlorine. So we have two reactions here. If chlorine is excess, ammonia reacts with chlorine gas and it forms nitrogen trichloride and hydrochloric acid. But in case if ammonia is in excess amount, right, if excess amount, less amount, also products will change. For example, carbon burning in presence of excess oxygen, what does it form? Carbon dioxide. If it is insufficient oxygen, carbon monoxide, even carbon black also, same. So ammonia, if it is in excess, what does it form? It produces ammonium chloride and it produces nitrogen gas. So these are the two reactions which you have to remember. The products where if chlorine is in excess or ammonia is excess, what are the products are expected? What is the gas released, whether HCl or nitrogen gas? Next, reaction with acids. What are acids? Sulfuric acid, carbonic acid, nitric acid. So how ammonia reacts with acids? It reacts with acids to form the respective salts. NH4Cl. When does it form NH4Cl? When it reacts with hydrochloric acid. Ammonium sulfate, when it reacts with sulfuric acid. Ammonium nitrate, when it reacts with nitric acid. And ammonium phosphate, when it reacts with phosphoric acid. So it reacts and it forms the respective salts. And remember, all these salts has one common use. What is the use, students? All these salts has one common use. All they are used as fertilizers for the growth of the plants, right? With HCl it forms white dense fumes as ammonium chloride. You can see the reaction, one reaction is given, NH3 plus HCl gives rise to NH4Cl, right. Next, test for ammonia, like how to identify the compound is ammonia. Ammonia has a characteristic smell, right. Yes sir, it's a very strong smell, so by that we can able to identify. Ammonia turns red litmus paper to blue color. This is also one of the identification technique on physical basis. By color change we can identify. Ammonia forms white dense fumes with HCl. By chemical change also we can identify ammonia. Ammonia plus HCl produces ammonium chloride, which are white dense fumes. So these are the identification techniques and uses of ammonia. Ultimately the main use you already know, it is used as a fertilizer. Ammonia is used as a refrigerant in the ice plants also, refrigerant cooling purpose. Ammonia is used in the manufacturing of fertilizers like urea, ammonium sulfate, all the ammonium salts. Ammonia is also used in the manufacturing of nitric acid, sodium carbonate and sodium bicarbonate. What is sodium carbonate? Washing soda. What is sodium bicarbonate? Baking soda. In their preparation also ammonia is used. Ammonia reacts with sodium chloride and it produces the respective sodium in the presence of CO2, produces sodium carbonates and sodium bicarbonates, which are washing soda, baking soda preparation also ammonia is used. So ammonia is also a good solvent, like we discussed. Ammonia can dissolve in water very easily, high solubility. So next, uses of ammonium salts. Ammonia is NH3. Ammonium salts means when it reacts with the respective acids, it produces ammonium salts. Why? Because ammonia is a base. Acids are acids like salt, base and acids. What does it form? Salt only, no? So all ammonium salts such as ammonium chloride, ammonium sulfate, ammonium nitrate, ammonium phosphates are used as a fertilizer. What is the role of fertilizers? Students, used for the growth of the plants. Ammonium nitrate is used in the manufacturing of explosives like ammotal and ammonal. So ammonium nitrate and ammonium nitrate has this explosive nature. Why? Because the compounds are a little bit unstable. So they are used as for explosives also. Ammotal is a mixture of 80%. These are very, very important, students. Ammotal is a mixture of 80% of ammonium nitrate and 20% of TNT. So dangerous chemical, trinitrotoluene. So that is ammotal, which is where it is used as an explosive. Ammonal is another explosive, a mixture of ammonium nitrate and aluminium powder, a small quantity. So these mixtures and their percentage composition, as well as what are the formulas of these compounds where these explosives are made up of, all these are important from the exam point of view. So that's what, students, about nitrogen gas and its famous compound, which is ammonia, and the salts which are produced from ammonia, like ammonium chloride to ammonium phosphate. All the salts we have very wide variety of uses, and in the next video we'll discuss about one more compound of nitrogen, which is nitric acid. So that's all, students. Thank you.